Good morning.
Hello.
Can everybody hear me? Okay. Yeah. Okay. Wow. Okay. Nice. Today, I think I'm going to go ahead and get started.
Video and your speakers on.
I can hear you.
Oh, nice. Awesome. Okay. Today, let me share my screen with you. Today, we're going to continue whiteboarding the the worksheet 3. And before you go clicking on this, I kind of want to try something a little bit different. I mean, we could still do it the way we did last time. So you'll click period 1 and period 1. There's a bunch of different folders here, but I've got one for individual people. You can do that way if you want. But I thought I kind of wanted to try something a little bit different. I got to set in on this this physics classroom at the college level, and they were doing something called, I don't know if you've ever heard of Discord. You ever heard of Discord? It's where you can kind of talk with other people. So what I was kind of thinking of, almost like classroom, where we'll get into a whiteboard, and when you get into that whiteboard, then what happens is then you can just kind of start working the whiteboard problem together. Well, I guess anyway, let me go ahead and shoot. Why can't I find the problems now? Anyway, let's go here. Save Riley's. We've already done problems 1, 2, 3, 1, 2, and 3. I thought maybe we could do 4 today. And so what I was hoping that we could do is you can actually get together with other people and whiteboard the problem together. You could go ahead and do it on your own individual one, but I kind of would like to form groups like we do in class if we could. So this other program, I don't know if it'll work. It might not work for you guys. I don't know. It's called Discord. And I've set up a class already. And what's kind of cool about it is you can go in here, and I've created different voice groups here, like group 1, group 2, group 3, group 4. You can put yourself in the group and you can talk, and you can hear each other talk while you're actually working on that whiteboard problem. So you can have this pulled up on the background, and then you could have this whiteboard up together, and then you can kind of draw on it and stuff. And I don't know, I'm hoping it works. So in the beginning, I think I just want to see if you guys can get into this Discord or not. I'm not sure if you will or not. So let me first copy this down. I'm going to copy that, and then I'm going to send it to you in an email. So if you could open up your email and look at that. I'm kind of interested just to see if this will work. If this doesn't work, that's fine. We'll go back to the way we were doing it, but
Okay.
I thought this might be kind of interesting to see if we could do it this way. Okay, so here comes the email, and there will be a link that you can click on.
Okay.
And I just want to see if it'll work or not. So check your email.
Okay. Sweet. He sent it to me.
Did you open it?
No.
Does he want you to open it?
Yes. Yeah, go ahead and open it.
Thank you. Thank you.
I can do it back.
I get out of here.
I'm not sure if it'll work, so I just want to try it out and see if you guys can get into it or not.
Just minimize that and go to your ow. Jeez, now I need get a smaller screen. Here. fine.
Is it working?
Yeah. Now go to your email. Email. That's how you do it.
I can't like see the email in my inbox.
Oh, so it doesn't work?
Uh-uh.
I guess I just can't. It's not in my inbox.
Okay. All right. Well, like I said, I wasn't sure if it'd work. That's all right. We'll do
Yeah.
kind of like what we did last week then. That's all right. Okay. So last week, what we were doing was we were whiteboarding these problems. And so what I'd like to do is I would like to give you a few minutes. What you're gonna do first is we're doing the problem number 4. You're gonna sketch a picture. After you sketch a picture of it, then you're gonna read through the problem and figure out if it's balanced or not. And here's your hint. It says that it's accelerating. Oops, sorry about that. It's accelerating, so that's your hint, whether it's balanced or not. Then you're gonna draw a force diagram, and then you're gonna solve it, okay? So I'm gonna give you about maybe 5 minutes or so to work on that. And by the way, if you wanna go into somebody else's whiteboard, you can go ahead and do that. You just won't be able to chat with them, okay? So I'm gonna stop sharing, okay? Go ahead and start working on number 4. And again, if you're like, I don't remember how to get to number 4, if you go to the calendar, you click on this link here, and then you go into period 1, and then go into your folder and go to problem number 4. Okay, so I'm going to give about 5 minutes.
Okay, so now go. Now, what are you gonna do? Read it, John. What does he want me to do?
Draw a picture.
Okay, I'll finish it.
Oh, man. You don't need to, do you? No. Okay. Sure need to draw some arrows, right? And upwards. Oh, we need to go upwards, so we need to move it down more. So we're going to go upward and do the take off from there. You're drawing like a picture of a force diagram now. Force diagram. It is a force diagram. You're supposed to do a picture.
Mr. Lindfest, I have a question.
Yes, question.
Which one are we whiteboarding? I'm sorry.
Number 4, it says a man pushes a child in a grocery cart.
Okay, thank you.
Okay, and again, and just do the best you can. Work on it for about 5 minutes, and then of course I'm going to show you how to do it. Okay,
Okay,
so just do the best you can.
okay, thank you.
Mhm. Okay, I'm gonna go ahead and I know you're probably not done. You're probably just starting on it. Okay. Can you guys hear me? Just yeah, shake your head. No. Let's see. Can you guys hear me? Yes. Okay. Um, so I'm going to go ahead and solve the problem. Hopefully you can. I think you can see my screen, right? Can you see it? Okay. So it says a man pushes a cart. You like my picture there? I drew that myself. No, I didn't. All I did was, if you're like, oh, how can I draw some pictures? You can actually go on and search the web, and I looked for somebody pushing a cart, and then I found one here, and I just copied it. So that's what I did. So you could do that too if you wanted to. It's kind of fun. And then it says he's pushing his cart, so I draw a force diagram. So I've done number 1 already. Here's my picture. Then it says read, figure out if it's balanced or not. Well, it says it accelerates. It's accelerating. So that means it's not balanced. So hopefully you can see the push force. Maybe I'll make it a little longer. The push force, it's much bigger than the friction force. But the weight force, the gravity, and the normal force, they are balanced. Okay. So I got that done. Then it says draw a force diagram. So I've got my force diagram here. And then finally solve it. Okay, well, there's only two equations that we have for solving. So let me circle those up here. So 2 equations. So it says that the mass is 30 kilograms. So down here for the gravity, if you look at this first equation up here, we know the gravity force is equal to mass times 10. So force of gravity is going to be equal to m times 10. And it says the mass is 30. So this is going to be 30 times 10. And so I go ahead and get my calculator, I figure out what that force is. And I get a force of 300. All good? Does that make sense? All good? Yeah? Yeah, okay. In fact, I don't know, can you guys, I think at the bottom of your screen, isn't there like some kind of, I was thinking there's something you could do, like you could show a thumbs up or something, but maybe not. Huh. I thought there was a thing that you could do that. I guess not. Okay, so maybe just give me a thumbs up with your hand, like maybe so I can see. Yeah, thumbs up, you get it? Okay. All right, so since it's balanced, I know the normal force has also got to be 300 newtons. Okay. It says that the force of friction is 15 newtons. So this little tiny arrow over here, this is going to be equal to 15 newtons. Okay, and then it says it accelerates at 1.5 meters per second. Remember, we have the equation F net equals ma. That's what we found from that last lab we did. So I'm going to write an equation over here on the left, and it's going to be F net equals m times a. Again, the m is 30, so it's going to be 30 times the acceleration of 1.5. And then I get out my calculator and I figure out what that is. Let's see, 30 times 1.5, 45, I believe. So what does that mean? Well, that means that when you add up all the forces together, you're left with only 45. Well, when you add the normal to the gravity force, because they're in opposite directions, you're not really adding, you're subtracting. They actually cancel one another. And the push force is in the opposite direction of the friction. That means the push is bigger than the friction by 45. So if I want to figure out how big the push is, it's going to be 15, the friction, plus the 45. So the push force from the guy, the dad, is equal to the 45 that we just calculated plus that friction force, 15. So can you guys get out a calculator and figure out what that is for me? 45 plus 15?
60.
That's 60.
Yeah, 60.
Thank you. That's the answer there. Perfect. Equals 60. Okay, so now we're getting ready to try the next problem. The next problem looks like, if I can find it, number 5. Looks like this. It says you have this cart and it's on this track and it's being pulled by a string. So kind of imagine what that looks like. Notice I kind of skipped over all the numbers. That's kind of what you want to do. You kind of ignore the numbers for a second to draw the picture. You just kind of ignore numbers. There's a cart that's on this track, kind of like we've done in class before. And there's a string on it that's pulling it, okay? So what I'd like you to do is sketch a picture. And if you want to go to the web, kind of like I did, and find some kind of cart on a track or something, you could do that. And then you want to draw your, figure out if it's balanced or not. Then you want to draw your force diagram and then solve it. So how about I give you about 5 minutes, okay? So try for 5 minutes.
Got it.
I have a 4 right now still.
Okay. You figure it?
Any questions? Guys doing okay? Okay. Again, I don't expect you to totally be done. I just want you to kind of start practicing a little bit. Okay, so I think I'm going to go ahead and show you my desktop. Okay. Oops, sorry, let me get that out of the way. All right, so I kind of went on the web again and I found a cart on the track. I was being lazy. You could have drawn one if you wanted to, but there's mine. And I actually kind of went to the last problem I did and stole the force diagram out of it because I realized it was going to have the same kind of forces, the force of normal, the gravity force. Instead of a push, there's a tension force because there's a string. So I just kind of changed the name of it. And there's still a friction force. I know that it's not balanced because, let me steal this. I know that it says that it accelerates. So that's why I noticed the tension force is longer than the friction force. Okay, so I've done number 1 and number 2 and number 3 as well. So now I just have to solve it. So I'm going to be using these two equations, the only two equations I really have. The net force is equal to the mass times acceleration. We found that in the last lab. And then the force of gravity is equal to the mass times 10. Found that in the very first lab, or maybe second lab of the unit. Okay, so I think I'm going to start with the force of gravity because it tells me what the mass is. The mass is 3. So it's going to be 3 times 10. Maybe I should write it out here. It's going to be mass times 10. And that's going to be equal to 3 times 10. And 3 times 10, that's 30. 30 newtons. So that means the normal's got to be 30 as well because it balances out the gravity. That's 30. It tells us that the string has a tension of 10 newtons in it. So I know what this tension force is. It's 10 newtons. Okay, so now I have to figure out what the net force is. So F net is equal to MA. And so I'm going to write an equation over here. F net equals M times A. Shoot, sorry. And that's going to be that mass again is 3 times the acceleration is 2 meters per second per second. That's what it says right here. So I get 6. So the total force is 6 newtons. So going to the force diagram, notice how the normal is pointing up and the gravity points down. So if I ask you what's the net force for those two, you'd say, oh, that's 0 because they're in opposite directions. Even though the normal's 30 and the gravity's 30, you might be thinking, well, at first 30 plus 30 is 0, or 30 plus 30 is not 0, it's 30 plus 30 is 60. But they're in opposite directions, so you have to subtract them. So it would be 0. The tension force is clearly longer than the friction force. In fact, if I want to know how much longer it is, I have to look at the net force. It's 6 longer than the friction. So if the tension is 10, I have to subtract 6 to figure out the friction. So I'm going to do a calculation here. I'm going to write it over here. The force of friction would be equal to the 10 newtons of the tension minus the 6 newtons of the net force. And so you get a friction of 4 newtons. Make sense? Any questions? Thumbs up if you get it. Yeah. Yeah. Okay. All right. Cool.
Yeah.
Any question? Okay. I think I think we're gonna try one more then, and I think that's gonna be it. So, whoops, wait, not that one. What the heck?
Number 6.
Number 6, sorry. Okay, so number 6, this one's a little bit tougher one. So it says a shopping bag can provide a force of 65 newtons before breaking. So imagine you went to a grocery store or something and you put 5 kilograms of groceries in the bag and you're going to try to lift the bag up. Okay, so I would like you to sketch a picture, or if you wanted to look on the web, see if you can find a picture of somebody picking up a grocery bag or something, or just a grocery bag. And then I would like you to figure out if it's balanced or not. Your hint is, notice it says it accelerates upward. Okay, then draw a force diagram and then solve it. Okay, so I'll give you about 5 minutes. All right, so go ahead and do that.
What do you need to do, Josh?
I get a grocery bag.
Okay, then can you type that? Josh, just type it in the Google. You can't, you're not gonna be able to copy and paste it. Go on to the, what you're looking for.
Put your force diagram in.
I should.
You in them circles. What do you think was there?
Just put. Oh, it's not
Remember,
push.
down here you got mass times acceleration. Those two equations. So you find your mass.
G, Brad. FG. It's like the easiest one. Right, where's it going in? It's over here and over here.
Well, what's your force? Is it push, pull? Is it, what is it?
This is. I think this is. I think this is first one. Over here.
Does anybody want a little bit more time?
Mm-hmm.
Okay. I think this is going to be our last one too. Okay.
What's your force? Is it push, lift?
Lift.
Okay. Now you gotta try your equation up here for down here.
What is it?
Same thing we did last time. Time.
Yeah.
So what's your M? What's your mass?
M is 10.
No. What's your mass?
That's 2.
Kari, don't worry about, we're doing number 6, but don't worry about it. You'll see it. I'm going to do it in a second for you, okay?
Okay, thank you.
Okay, I think I want to go ahead and show you how to solve it. So don't worry if it's not done. Maybe you can kind of keep working along with me, okay? So this is number 6 then. So you can see I found something on the web just to make it a little bit interesting, I guess, and I drew a kind of a stick person. You can do whatever you want. So they're kind of lifting this bag straight upward. So that's why I have the arrow up there. So what's kind of nice about this problem is I think there's only 2 forces. There's a force downward, and then there's some force upward. I didn't really know what to call that force. I called it a tension force. I suppose you can call it a pull force, maybe. So something like that. Or maybe you might call it a lift force. I don't know, because it says it's being lifted. But there's 2 forces for sure. It says that it's accelerating upward. So that means it's not balanced. So that means the tension force, or whatever you call them, that upward force, is bigger than the gravity force. All right, so I've got my picture. I figured out it's not balanced. I've drawn the force diagram, and now I just need to solve it. So I only have 2 equations. Those are the equations I'm going to use to solve this. This new equation, F net equals ma, and one we found at the beginning of the unit, the weight's equal to m times 10. So I'm going to start off with the weight, Fg. So Fg is going to be equal to m times 10. It says that the mass, if you read through it, it says the mass is 5 kilograms, 5 kilograms of groceries. So I'm going to put equals 5 times 10, which that would be equal to 50. Sorry about that. There you go, 50. Okay, notice it's not balanced. So this tension force is not going to be 50. It's going to be more than 50. To figure out how much more it is, I have to figure out the net force. That's the m times a. So I'm going to do a little side calculation here. F net. Stop me if any of this doesn't make sense, if you have questions, okay? F net equals m times a. Again, the mass is 5 kilograms. So 5 times, the acceleration is 2 meters per second squared, or 2 meters per second, so 5 times 2. And so the mass is, or excuse me, the net force is 10. So what that means is that that tension is 10 bigger than the gravity force. So let's see if we can do a calculation there. The force of tension is bigger than the gravity force by 10. So it's going to be 10 plus 50. And so when you solve this, you end up getting, I think that's 60. So the tension force is 60. We're not really done with this. I'm going to get rid of these circles so that it's not distracting us. It says a shopping bag can provide a force of 65 newtons before tearing. Make sure I did this one right. Yeah. If the shopper provides a lift on this bag with an upward acceleration of 2 meters per second squared, will the bag break? Well, notice the tension force here is 60. It can have a maximum force of 65. So will this bag break? Yes or no? Will the bag break?
No.
No, yeah, no. So I don't know if you've ever been to a grocery store. Sometimes they double bag things, so you don't want it the bag to rip on you when you lift it up. So this one we don't have to worry about. But if they would have accelerated much more, because it's pretty close to 65, if the let's see, if the acceleration would have been 3, let's think about that. 3 times 5, that would have been 15. 15 plus 50, that would be 65. So if the acceleration would have been 3 meters per second, it would have ripped then. So any questions on that? Okay, so I think that's it, but don't go anywhere yet because I'm going to show you then. Let's see here. We haven't finished that. We'll finish that then on Thursday or Wednesday. By the way, another 7:45 meeting on Wednesday. We'll whiteboard the rest of it. If you want to work ahead, you can. You don't have to. Since you guys are, oops, did I stop sharing, didn't I? Hold on a second. Sorry about that. Sorry about that. Let me try that again. All right, so Wednesday, we will have another 7:45 meeting. We'll finish whiteboarding worksheet 3. If you guys want to work ahead and do that yourself or try it, you can. You don't have to. You guys, since you're all here for the meeting, you do not need to do this little attendance quiz. That's only for people who are absent. They're going to have to watch the video and do the attendance quiz, but let me go ahead and tell you about it. Not that you need to take it. But if you wanted to take it, if you want to do some practice, because it's kind of like the problems we just did, see if you really understand or not, it's good practice. You'll need this access code though. It's capital E, capital V, lowercase y-a-n, and then 7976S. Tell you what, you don't have to do it, but if you would like some bonus points, I know some of you could probably use some bonus points. If you want some bonus points, you can go ahead and do it, and I'll give you bonus points for doing it. It's similar to what we just whiteboarded. So it's up to you if you want to do it or not. Okay, any questions? That's it then. See you later. Bye.
Oh, true.
Devante, you sleeping? No. All right. See you later, Devante. Bye. Oh, my Lord.